start again. Hi, I'm Ms. Boom. Let's have a look at translations of functions. Here we have 3 points A, B, C. What happens when we translated -3, 2, or in other words, -3 in the horizontal direction and 2 in the vertical direction? Instead of saying moving, I'm going to use the word translate. So the point A is now at 4, 2, the point B is at 4, 5, and the point C is at 6, 2. And I'm going to move the point A 3 to the left and up 2. So I end up at 1, 4. So I'm going to switch the word move to translate. So I'm going to translate the point B from this point to 3 to the left and up 2. So I'm going to end up at 1, 7. More accurately, I can say that I'm translating the point C 3 units in the negative direction of the x-axis and 2 units in the positive direction of the y-axis. So I end up at 3, 4. How do we generally describe this? So the point xy has been moved or translated and has been moved to the point x minus 3 and the point y plus 2. We describe this as our original coordinate and this as our image of the original coordinate. So this here is the image. And this transition is called mapping. So xy has been mapped to x minus 3, y plus 2. Let's do an example. Translate the set of points defined by the function xy, where y equals x squared, by the translation defined by xy to, or map to, x minus 3, y plus 2. So how would we describe that? So let's start with looking at each point. So the original point, we're going to call it xy, and the image, we're going to call it x dash and y dash. So the image is x minus 3, or in other words, and the image of y will be y plus 2. So if we rearrange this to see what x is equal to by bringing the -3 over, we can see that's the image plus 3. And likewise, we can rearrange this, isolate y, we obtain y dash minus 2. So by substituting this into the original equation, we can get our new equation. So let's do that. So original equation, now we substitute the y with our new y dash minus 2, and we substitute the x plus 3. And when we rearrange the minus 2 to the other side, now we can see that we obtain x plus 3 squared plus 2. And it makes sense. Remember, we used to say x plus 3 means moving to the left by 3. See? And plus 2 means we're going up by 2. So now you can see where we get this equation from. Let's have a look. So x squared looks like that. And what does x plus 3 squared plus 2 look like? It has been translated to the left by 3 and up by 2. This process really helps us to understand why we always have x minus h in the bracket, but slide x in a positive direction. So remember, when we have x minus 5, for instance, we would have moved the parabola 5 to the right. Now we can see what happens. So to recap, so we write down the image is whatever it is, so x minus 3, for instance, and we rearrange to isolate the original x, and we substitute it into the equation. So rearrange, then substitute. Remember those 2 steps. Example 2, find the equation of y equals f of x, where f of x is equal to 1 over x under a translation of 5 units in the positive direction of the x-axis and 7 units in the positive direction of the y-axis. So let's figure out what that means. So f of x is 1 over x, and we have our x, image of x is moving to the right by 5, so plus 5, and the image of y is also adding 7. So therefore, rearranging, we would get x equals the image minus 5 and y equals image minus 7. Now we substitute into the equation. So let's do that. So the y dash minus 5 will go where x is. Sorry, x dash minus 5 will go where x is, and y dash minus 7 will go where y is. So then we obtain this. So the graph of y equals f of x is mapped to y dash minus 7 equals 1 over x dash minus 5. More often we would rearrange that, so now we have the 7 on the other side. So we have y equals 1 over x minus 5 plus 7. And again, it makes sense. Remember when we said minus 5 is moving to the right by 5? See, the question is saying 5 units in the positive direction of the x-axis. And then we said plus 7 means up 7 previously. And again, see, plus 7 means up 7. Example 3. Find the equation of the image of the graph of y equals f of x, where f of x equals square root of x under a translation of 1 unit in the negative direction of the x-axis, so 1 to the left, and 2 units in the positive direction of the y-axis, so 2 up. So let's start by writing the equation out. And then we say, so 1 to the left means minus 1, and 2 up means plus 2. Then we rearrange. So now we have x plus 1 and y minus 2, and then substitute it back into the equation. So we have that part is y minus 2, and underneath the square root where x is, we're going to put x plus 1. Now rearrange so that the 2 goes to the other side, and now we have our image. Again, look at the description. So it has translated 1 in the negative direction, see, 1 to the left, and up 2. In summary, for the graph of y equals f of x, the following two processes yield the same result. Applying the translation xy mapped to x plus h, y plus k to the graph of y equals f of x is the same as replacing x with x minus h and y with y minus k. Notice that it's the opposite operation. In the equation to obtain y minus k equals f of x minus h and graphing the result. Thank you for watching. I'll see you next time. Bye!